Hello, myself Mohammad Danish Hashmi, and today I am going to discuss about differentiability. Before starting about differentiability, we must know what is differentiability. Okay, so we are talking about differentiability. So differentiability of what? Obviously, differentiability of a function. So what is means a function is differentiable or not? Okay, the basic definition of differentiability or the basic concept for a function to be differentiable is the unique tangency. Okay, if we are talking about a function and a function is differentiable, then it must have unique tangent at all points. Let's see this by an example. If I have a function like this or a function like this, so in this function, if I take any point and draw a tangent, then let's say I am taking this point at x equals to a. So at x equals to a, there is a unique tangent. Okay, but if I talk about this graph, let's say this point is x equals to a. So at x equals to a, graph have a sharp turn. Okay, so if I talk about tangency at this point, so there is two tangent occurs. Okay. But for a function to be differentiable, the tangent must be unique at every point. Okay, so it is clear. So we are okay. So we are going to study about differentiability. So differentiability of a function, and a function is said to be differentiable if it has unique tangent at every point. Okay. There is some other name of differentiability is also derivability. Okay. So both name are same, differentiability or derivability. Derivability means a function which is able to differentiate. Okay. So if there is a the differentiation of a function is possible, then the function is known as differentiable function. Okay. So derivative of function, we study the derivative in two aspects. The first aspect is physical. First is physical and another is geometrical. Okay. So we study physical aspect of derivative generally in physics. That is also known as instantaneous rate of change. As for example, in physics, we say that instantaneous rate of change of velocity is dv by dt, and it is known as acceleration. Okay, so this aspect of derivative is also known as physical aspect, but in mathematics we study generally the geometrical aspects of derivative. So let us study about the geometrical aspect of derivative. Okay, so here before starting geometrical aspect, let's discuss about tangent. What is tangent? So in geometry, I can explain it with graph. Okay, so if I take 2 points on this graph, say A and B, okay, and if I join these 2 points AB, so there is a second AB. Now if B start moving towards A, then finally this will becomes a point, a time occurs when B is at point A. Okay, it means both 2 points coincide. So at that point, at point A, this will become tangent. So I can say that the tangent is the limiting case of secant. Okay, so this will be tangent and it will be the limiting case of secant. As B moves towards A, and when A and B coincide, then at A, this line becomes tangent. Okay. Now, there is two possibilities to move this point towards B. Either we can move this point from right side to A or from left side to A also. Let's take another graph like this, and I am talking about this point, say x equals to A. So at x equals to A, the coordinate of A will be A and f of A. Okay. Let's say there is a small increment in A, and I can say that it is h, and h is very small, it tends to 0. So this point becomes A plus h, and this point, let's say this point is B, and coordinate of B will be A plus h f of A plus h. Okay. This can happen either side. This happens from right side to A, so this may also possible from left side also, and let's say this point is B dash. Okay, so this point will be same, A minus h to the left of A, and the coordinate of B dash will be A minus h and f of A minus h. Okay, now if I have secant AB, if I take limiting case of this secant from right side, then it will become tangent at x equals to A from right side. And if I take limiting case of secant from left side to A, and this will become tangent at x equals to A from left side. If both the slope of this tangent is equal, then I can say that at x equals to A, there is a unique tangent. Okay, and the condition for a function to be differentiable is the unique tangency. Okay, so we can write this information mathematically as I am taking from right side to A. So the limiting case as h tends to 0, the slope of this secant become tangent, and the slope will be f of A plus h minus f of A upon A plus h minus A, and this A will be cancelled out. So finally we have limit h tends to 0 f of A plus h minus f of A upon A. Okay, and I say that this is right hand derivative. Okay, for left hand derivative I can write expression as limit h tends to 0 f of A minus h minus of f A upon A minus h minus of A, and A will be cancelled out. Then finally I have limit h tends to 0 f of A minus h minus of f of A or minus of h, and this is known as left hand derivative. So for a unique tangency, both the inclination or slope of both the tangent will be equal, so that this will be a single tangent. For this, there must be LHT equals to RHT and it will be equals to derivative of fx at x equals to a, and this all value must be a finite one. Okay. If any function follow this condition at x equals to a, then I can say that the function is differentiable at x equals to a. It means the function has unique tangent at x equals to a. So this is also the classical definition of differentiability. I can understand this by an example also. Let I have a graph here like this. Okay. And I take at x equals to a. If I take tangent from right hand side, so this will be like this. Okay. If I take tangent from left hand side, so this will be like this. And from both sides, the slope will be equal. So I can say that at x equals to a, there is a unique tangent. So that this function is differentiable at x equals to a. If I take another example, let's say like this graph. So this point is x equals to a. If I try to find out this function is differentiable at x equals to a or not, so I take this basic. If I take tangent from right hand side, so this will be like this, and if I take tangent from left hand side, so this will be like this. So at a single point x equals to a, there is two different tangent is possible and both have different slope. Okay, so there is no any unique tangent at x equals to a, so I can say that the graph of this function is not differentiable, but means this function is not differentiable at x equals to a. Okay. So in short, I can understand if a graph have sharp turn, then the function is not differentiable where the graph takes sharp turn. Okay. Or if a graph is discontinuous, then also function is not differentiable. So this complete is the classical definition of derivability or differentiability. I hope this make you understand, and we will discuss in detail in next session. Thank you.